Yes, good morning. This is John Brito, working as assistant professor in the Department of Mechanical Engineering in the College of Engineering Technology. So now I would like to present a topic in engineering graphics or engineering drawing. It's a very important topic. It's nothing but sectioning. So I'm going to use software called AutoCAD to explain the concept so that you can understand the concept in a much better way. So this is the question. Sectioning, I'm going to use a cylinder. I'm going to cut a cylinder and I'm going to draw the front view, top view, sectional top view and true shape of the section. So a cylinder, so I'm going to divide the question into two parts. The first part is the normal front view and top view. Second part is about sectioning, and third part the end result, right? So to start with, the first part of the question is the cylinder of diameter 60 and height 60 is given. So what I'm going to do is I'm going to simply draw a circle of 30 diameter. Then I'm going to divide the circle into 8 equal parts. So to make the projections easy and to get, so for that we are dividing the circle into 8 equal parts. We can either divide 8 or 12. So I'm going to make it as 8. After dividing the circle into 8 equal parts, I'm going to name the components. I'm going to name the components, name the points, okay. I'm going to name all the points. So I'm going to name this as A1 and this as A1, B2. I'll explain why I making it this way. See, cylinder has two ends, right? So top ends, so just imagine a cylinder, the top end, I'm dividing the circle into 8, okay? So each point I'm naming as alphabets, A, B, C, D, E, F, G and H. The 8 divisions I'm naming in alphabets. The bottom division, same. Similarly, the bottom divisions, 8 division, naming as 1, 2, 3, 4, 5, 6, 7, 8. So when I see from the top, I can see the alphabets, but the numbers will be hidden. See, A, under A, there will be 1, point number 1. Under B, there will be the top side, it is ABC, and bottom side is 1 to 3. So when I look at the point A, under point A, there will be 1 at the bottom side. So which means A is visible and 1 will be hidden. Okay, so A, I'm naming in this way, A in bracket 1, B in the bracket 2. Similarly, I'm going to name all the points. Okay, C3, D4, okay, I'm going to name all the points such a way. Okay, similarly, then after naming it, what I'm going to do is I'm going to project all the points, okay, to draw the front view. You know, the front view of a cylinder will be a rectangle. I'm going to project all the points like this. See, I'm going to project all the points. Then what I'm going to do is I'm going to draw the front view. You know that the height is 60. I'm going to project all the points like this. I'm going to project all the points. So the center line alone, I'm going to I'm making it as a axis line. Then after doing it, I'm going to name this. How I'm going to name this? See, as I said, it is A, B, C at the top and 1, 2, 3 at the bottom. So here, by that, I said that A will be here and 1 inside the bracket. So based on that, see, this point is A and this point is 1. so that when I see from this side, from the top side, A will be visible, 1 will be done. So A inside the bracket 1, A of 1 I have done it. So similarly, I am going to name all the other points. See, I am going to name the other points as well. See, this is B of 2. So we get B of 2. This is H of 8. H, we can see from the top, H is visible and 8 will be under the point H. So H is visible, 8 will be done. Here C of G. Sorry, C3. C3 it is here. G is visible, 7 will be invisible. All the alphabets will be visible. Okay, in the case of top view. But in the case of front view, see, when you see a cylinder from the front, you can see the rectangle only. So A will be visible, B, C, D, E only will be visible. Okay, when you see from the front, the H point will be behind the point B. Okay, the G will be behind C, F will be behind D. So I have in the case of the front view, I have given that in the bracket. Okay, so there is two ways to understand. Fine. Then, so the first part of the question is over. The second part will be I have to move on to my cutting plane. Okay, the position of the cutting plane, it is where and how it is given. So it is inclined 30 degree to HP, perpendicular to VP, and that cutting plane bisect the axis. Bisects in the sense it is equal of that. So which means the total height of the cylinder is 60. So I am going to divide the 60 into equal of. See, this is for 30. I have made it right. Okay, this is total 60. So for 30, I have drawn a line. And with respect to that, based on this, I am going to draw the cutting plane, which is inclined 60 degree to HP. If it is HP, you know that you have to make it in VP. So 30 degree, I am going to draw a line for 30 degree. So hope it is clear till now. So 30 degree, I have made a line. So let me check the angle. So angle is 30 degree. So anyway, I'll do it all this. Fine. After doing it, what I want to do is I have to draw the sectional top view as well as the true shape. First, I'll start with my sectional top view. How to draw the sectional top view? It's very simple. Okay, you have to take your compass. Right? No, sorry. Just we have to project all these lines to this. Okay. See, this is the point where the cutting plane and the generator. These are the generators. Okay, these are the generator. Vertical line are called as generator of the cylinder, and this is called the This is the cutting plane. Okay, now I'm going to mark a point where the cutting point and the cutting plane and the generator meets. So this line is. So this is the point where the cutting plane and the generator meet. So I'm going to name it. Similarly, this is the point where the cutting plane generator meet. Here, this is the point where the cutting plane and the generator meet. So I'm going to do for all. So these are the points. So I'm going to name as such. So I've named it as P, Q, R, S, and T. So P is the point where the cutting point and the cutting point and the generator meets. Okay, Q, R, S, and T. These are the points. After naming it, what I'm going to do is I'm going to project these cutting points. Okay, vertically downwards. See, P I'm going to project here till this point. Q I am going to project here till this point as well as this point. R I am going to project till here and here. when I project this, okay, this cutting point meets the circumference of the circle, right? So it meets the circumference of the circle. So this P meets here, this Q meets the circumference of the circle here and here. This R meets the circumference of the circle here and here. S meets the circumference here and here. T meets the circumference here. So I have transferred the points, the cutting points to the top view. After doing it, what I'm going to do is I'm going to do something called as hatching. Okay, this is hatching. I'm going to do something called as hatching. I'm going to pick the boundaries. I'm going to pick the boundaries like this. Okay, I'm going to pick the boundaries. Then I'm going to go for hatching. I'm going to use 45 degree, right? I'm going to use 45 degree, and I'm going to scale. Maybe I'll go for 2. Okay. Okay. So this is what I'm going to do, right? So I've done with my hatching. This is called as hatching. Hatching is nothing but it is what it is. It represents the, it is the sectional top view. The normal one, it's called as top view. When I do hatching, it is called sectional top view, which means when I cut, remove something, the remaining portion. This is how, see, the cutting plane. This is the cutting plane, right? So I'm going to do one more thing. So I'm going to see. See, I'm going to highlight this. I'm going to make this dark, which means this is the remaining portion. See, the cutting plane cuts a cylinder at this point in this angle. The top portion has been removed, and this is what the remaining portion is all about. Okay, so this is the remaining portion. This is how the front view will be. When I look this cylinder, this is how the top view will be. Okay, in order to represent it as a section top view, I am making this, right? Similarly, I'll darken this also. Okay, then what next? The final part of the question is the true shape. What I'm going to do, see, I'm going to project all these points. Before that, I'm going to draw a line parallel to this cutting plane, like this. Okay, then I'm going to name it as x1 and y1. See, I've made it in this way, x1 and y1. Then after doing it, I'm going to project this cutting points like this, vertically, like this, upward. I'm going to project all the cutting points like this. Okay, after projecting the cutting points, what I'm going to do is, okay, I'm going to take a compass. Okay, I'm going to measure the distance, that is from xy. I'm going to measure this. See, we have projected this point now. So from xy, I'm going to project this, measure this, and I'm going to transfer it here. So from xy, I'm going to measure this, and I'm going to transfer from x1, y1. Similarly, I'm going to do it for all the points. So finally I'll get a point here, 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 and here. Okay, after getting it, I'm going to join all the point with the freehand sketch. Okay, I'm going to join all the point like this. Finally, we'll get an output, and I'm going to hatch it. So I'm going to hatch it using this software, this thing, and I'm going to hatch it, and I'm going to finish it off. Okay, so this is all about sectioning. See, we have to project from xy, we have to measure, and we have to make it to the x1, y1, and we have to make, and we have to complete the thing. Thank you.